I don't even have a intro.
And I just realized I don't have Audacity open. So clearly we're both highly well prepared today.
We are professionals. The most professional of the professionalists. Oh, and Astrosphere is down. Oh, wait, there it is.
Okay, minor panic averted.
And we didn't announce the funding last week in Astronomy Cast, did we? So
yeah, we did. We did in
we?
the yeah. And the press release isn't out yet because some of my partners don't have their contracts yet. So when I put the press release out, we'll totally announce this even more. Okay. But yeah, I think people did catch it on the YouTube.
No, but they caught it at the end in the Q&A part. Yeah. Okay.
Yeah. So people are going back and watching the YouTube because I heard about it today from somebody.
So I'm still enjoying what is probably shingles.
Oh no.
Yeah. I told you about this, right?
Don't go near pregnant women. You and mosquitoes.
All right. Let's see. Do we even have a name for this?
I put predicting the future.
Predictions for 2016 and beyond. Yeah. Okay.
Okay.
Predicting future of astronomy, space, future predictions in space. There we go. Future predictions. That's what I'm calling it.
Oh, I'm so happy. Yesterday's Apple update seemed to have finally fixed the Twitter app. It was borked. Yay. Small pleasures.
Hello to people?
Hello, people.
No. Specifically in the Q&A app.
Oh, I can do that. Yes. Sorry, I was being distracted by the fact that Twitter works. Hi, people. Hello, Ryan Schmitz, Guido Bibra, Matt Woods, all the way from down under. Stefan Walker, who's observing or getting ready to image. That's cool. We want to see your pictures. Oh, but Gazelle, I'm not sure how you say your name, is getting rained on in Montreal. Thomas Treneker is out there. We're spanning the globe. This is awesome. Hello, Billy Gordon. Hello from Hull under Permacloud, England. Yes, that is a thing. Hi, John, from under the Permacloud. At least it's not under the permafrost. You're not going to someday be a frozen museum relic. So Fraser is madly typing because we realized we weren't as entirely put together as we meant to be for this special Wednesday episode. We're easily confused. For those of you who were confused on Monday, I had National Science Foundation panel reviews to be in, so I was doing my due diligence as a scientist and talking with my peers about how to support our peers and stuff and things. And yesterday I had all day meetings and Fraser had life. So today is Astronomy Cast.
Yeah. So today we're going to predict the future, we hope, because episode 400, we did our look back over everything that's changed since we started Astronomy Cast 9 years ago. Today we're going to this is going to be the silliest show. We are just going to baselessly speculate on what's going to happen in the future.
In science, not in the presidential elections. Just to be clear.
I don't know. I can't promise that I won't. We will try to extrapolate.
Can we have yours? Can we take your prime minister?
Yeah, totally. He's awesome.
Yes.
Have you seen that post that went around about all of the cabinet members that Trudeau appointed that are our Minister of Aboriginal Affairs is Aboriginal, our Minister of Transportation is an astronaut, our Minister of what is it? And someone one that's openly gay. We have one that's openly ginger. Yeah, but it's just a great. Listing, so I don't know how Trudeau's going to be as a prime minister.
So far, he's awesome.
But he picked a good team, which you can't go wrong. Come on, Mark Garneau is our Minister of Transportation, which is just the greatest thing ever. So for Women Affairs, he picked a woman.
Who'd have thunk? Who'd have
Who'd have
thunk?
thunk? Yeah, exactly. So anyway, yeah, no, we are, and of course, Carla, my wife, is really kind of. It's funny to watch her kind of rabbit hole. You know,
She's an American.
she's an American, and so she has to vote, even though she's here in Canada. She's gonna have to vote to pick the president, and it's hilarious to watch her just rage at the choices that she has available to her. So anyway, on both parties,
So my Canadian husband, on the last election season, we live in Obama's old senatorial district. So there's no advertising here. They've just given up. They know who we're going to vote for.
Yeah,
they've given up. And when on Monday I was like, I'm going to go watch the caucus results, he's like, wait. What's going? He couldn't believe that we're already starting the voting process in our own twisted,
we
takes an entire year kind of way.
I know. Here in Canada, we get it's time to vote next month. Don't forget to vote, and then you show up and you vote. Right, like that is, I'm boiling it down a little bit, but we don't make a big deal about it in the same kind of way. I feel a little let down. It really, I get way more entertainment out of following the U.S. Elections than I do from the Canadian stuff. It's just there's so much more going on. It's like it's amazing. Anyway, well, let's do a show. Let's do an episode of Astronomy Cast. So, and then of course we'll stick around and answer some questions about space and astronomy. And one last thing, the astute of you will know that we used the YouTube live streaming app last week for the weekly space hangout. But this week we're still using the old way, which is to use the method through Google Hangouts on Air. So this is probably going to change for next week. And the one thing that you're going to want to do if you want to be able to watch this live is you're going to want to follow Astronomy Cast, subscribe to the Astronomy Cast channel on YouTube. So if you're not already doing that, you're going to want to do that. And that way you should, and then set yourself to get a notification, and then you should get notifications and lots of sort of good information about when we're doing the live show. It worked out really well. The chat was great. It was a much better experience than using the system that we use now. So this is the last time we're going to do this the old way, and then we're going to do the new way. And I know everyone is always used to my wrenching change that I am always, I'm never happy. Everything's got to be different, but I promise this one's an improvement. So
and the open question that I'm just going to throw out to the audience is CosmoQuest. When we had to go through Google Plus, we ended up with the Learning Space YouTube, the all of these 10 million different YouTube things, and we didn't want that. So should we just merge it all into one YouTube account? We are asking you, audience, help us figure this out.
Well, as part of your audience, I think it should be just put into the CosmoQuest or Astrosphere channel. Is what I would probably do, but that would be me, because you just want to have one place. But I mean, some people, it's weird. You see popular channels and they break it up. So where they, like Vsauce has Vsauce, and then they have Vsauce 2, and they have Vsauce 3. So
yeah, we're confused.
So confused.
We should record.
Okay, let's do a show. Man,
I have Audacity open and all that stuff.
I have attention deficit disorder open. So
okay,
all right.
I am audaciously clicking play, which wasn't the right button. I'm now pressing record, and it's recording.
I have pressed record. We're recording.
That's the correct button. Yeah. Hi, Preston. We're ADHD today. We're sorry.
You're totally. Okay, here we go.
Or at least caffeinated.
Oh, I could have another cup of coffee. Okay, Astronomy Cast, episode 401, Future Predictions. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos. We help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Doing great. So I just want to let people know that we are switching the way we do the live show of Astronomy Cast. So we were doing it through Google Plus, Hangouts on Air through Google Plus. We're switching to YouTube Live for reasons. But the thing that you're going to want to know is if you haven't already, go to YouTube, find the Astronomy Cast channel, and subscribe to it. and then you should get notifications in your telephone or into your email inbox or your Google notification little jobby when we've got new shows happening, and we're going to be live streaming, which is great, because if you've always wanted to catch us live and you always miss it, hopefully you'll get a better notification. That the chat for being able to talk with each other is a lot better. So that's going to happen for next week. So if you haven't already, go to YouTube, subscribe to Astronomy Cast channel, and then kick back and enjoy the space. Okay, so last week we updated everyone on what's happened since we started Astronomy Cast 9 years ago. So now we're going to look forward and predict the future with hilarious results of what we think will happen in the near and far future. So I've put together a bunch of categories, Pamela, and what I thought we would do is that we would just be pundits. Let's just sort of talk about the different topics that I've outlined here, and let's try to make some predictions on what we think is going to happen based on trends that are going on, about the complexity of the science, about all this kind of stuff. Are you ready?
I'm gonna try. I'm over caffeinated. That's the best I can hope for an episode like this. It's over caffeination. Right.
Okay, so let's start with what I think is one of our favorite topics, and this is extrasolar planets. And we made a big deal last week about how much extrasolar planets have changed since we started doing Astronomy Cast. What do we think the future holds for the science of extrasolar planets?
I'm really looking forward to being able to do better spectroscopy of the atmospheres, and I'm going to keep saying this, that within the next 10 years, I'm thinking we're going to find that first world that has some atom or molecule that can only exist if there's life, hopefully molecular oxygen. So that's the big thing that I'm looking for. It may not be in the next 100 episodes, but it's going to be the next big thing.
Okay. So hopefully by the time we do, maybe not the next couple of shows, but we should hopefully see some sign of an atmosphere, or detecting and analyzing atmospheres will become a lot more commonplace.
Yeah.
But that there will be just hopefully a discovery of some of these really interesting molecules, the ones that indicate the presence of life.
Exactly.
Yeah. Okay. What about finding Earth 2.0? I mean, do you think? I mean, the sad part about Kepler, like Kepler was designed to find Earth 2.0, but Kepler had its failure with its not enough gyros problem, and so it wasn't able to turn up Earth 2.0. The Earth-sized world, our sun-like star in the habitable zone. So, do you think? When do you think that's going to come around?
That one has me a little bit more perplexed, because when you talk about Earth 2.0, I think finding one would be easy if we would just get lucky with the right telescope. But because right now we're going to have to find it with probably Doppler shifting or one of those other can't look at a million stars at once sort of technologies, it relies on luck. And when it comes to luck, I'm a lot more, I don't know what to say.
Yeah. Well, I mean, it feels to me like, and I've tried to get people to admit it, that the data is in there in the Kepler.
But we don't have enough years of data.
Well, we don't have enough years of data, but I'm guessing there's enough kind of hints that using other telescopes and ground-based observatories and other ways, they could try to confirm some of those hints as actual planets. So I feel like we're going to see an answer to that. I was sure we would have seen an answer to this by now. I'll bet you within the next couple of years that we're recording this, we will have found that true Earth 2.0, I think.
I'll go with your prognostication.
And then we've got all the other observatories, right? We've got Gaia, which isn't really specifically designed for that, but it can do some planet hunting in a heartbeat. And then there are other ground-based missions that are doing a really great job of finding worlds. So, what's going to happen when the large Magellan telescope, or the overwhelmingly large, extremely large telescope, the 30-meter telescope gets online, right? Things like that. Although it might not get built.
The thing with those is they're not really designed to do this kind of survey work, but LSST, it's certainly going to be chewing them out.
Yeah.
So atmospheric willing, yeah, it's LSST is probably our next big hope for spinning out planet after planet after planet within the error bars of a ground-based, prone to dealing with the atmosphere kind of telescope.
Okay. Astrobiology, which is sort of related to this, search for aliens. So what do you think about SETI? Do you think we'll get a signal from SETI soon?
You know, that one I place at very low probability just because of the energy requirements. And what we're finding here on Earth is the more advanced our civilization gets, the quieter we get. Just in terms of we're using lower energy transmission, we're doing more cable-based transmission, fiber optic-based transmission. So unless they're beaming a signal straight toward us, I think that life is going to be found, again, back to the atmospheric argument.
Yeah. Yeah, I totally agree. And here's sort of the way I think about it, is that any alien life form within thousands of light years, any advanced civilization within thousands of light years knows that there's life here. And knows, you know, right? And that they would have predicted the oxygen, like we're going to do it. They would know that there's oxygen on this planet that's being produced by life. And they would have, you know, they might, if they're 2,000 light years away, they're looking at us 2,000 years ago, they're starting to see fires, starting to see, you know, wood burning fires and things like that. And so they could almost know what phase of technology, and then they could send signals directly at planet Earth with the kind of amplitude that they know we would receive. And so I feel like because we're not seeing these signals, that we're not going to. That's just like my sort of Fermi paradox version of that thought process. So I don't think we're going to get a signal from SETI.
Yeah, the kinds of exceptions are like, I've brought this book up so many times on the show, Mary Norris Russell's The Sparrow, where they detect a alien civilization because the planet's moon is reflecting back radio, and they detect the music in the signal. But that's a special, lots of geometry, and it's fiction, for crying out loud.
Yeah, also fiction.
Yeah. So
and so I think you're right, right? It's like
yeah.
an unintended signal is going to be really hard to receive. The only ones we're going to be able to receive are the ones that are blasted right at Earth. Yeah. With a really coherent beam. So that's my feeling. Sorry, Seth Shostak and the folks at SETI. That's my feeling.
We still love all the other research you're doing. Keep doing it.
Totally. Yep. So let's talk about the other kind of astrobiology, which is finding life in the solar system.
I think it's just a matter of figuring out how to sterilize things well enough to go in and look at the places that life is likely to exist. I can't imagine, given the amount of shrapnel that we've sent around the solar system when the Earth has gotten hit, and the amount of basically cross-pollination of rocks, that we're the only world that has life. And I hate to think we're the only place that life evolved to begin with. So as we find that Mars has admittedly perchlorate laced soils with waters, very briny waters, but that doesn't stop stuff here on Earth. As we realize that Titan's atmosphere is chemically out of balance, as we look at all of these moons and asteroids and everything else that has water and frozen water and subsurface water, let's start sterilizing things and sending them out.
Yeah, I mean, I think the only thing that's hampering this is that there just aren't a lot of missions that are really purpose-built yet to do this search for life. Someone's not making the Martian life finder. And
it was actually a congressional mandate here in the United States that NASA was not allowed to look for life.
I know.
Then we realized, wait, it might be here. Well, not here. We think there's life here. We pretend there is, but there might be life on Mars, like for reals, guys. And so it's now become the follow the water.
And so exactly. And so they're doing it sort of half. They're sneaking it in, right? They're searching for water or searching for ancient water. But if there are no plans in the works to send the Martian Life Finder mission, which would go with like 14 different experiments to search for life, to smell the atmosphere, to lick the rocks, to take soil and run experiments on it. And I think that's what you're going to want to send.
And really only the robots should be licking the science, because all the rest of us would just contaminate stuff.
Yeah, no, only robot tongues tasting the rocks. But geologists do this, so this is not. I'm not.
No,
I'm not a crazy person.
I know. I actually have a sign on my door: "Do not lick the science."
No.
But the thing is, there's like part of me that keeps hoping with these close-up zoomy cameras and the ability to bevel in that Curiosity has, that we'll like find fossilized shrimp or something.
Yeah, or like little fossilized, shrimp, or like some kind of seashell, or that would be amazing.
And that's probably overzealous wishful thinking, but I'd settle for like single-celled mats of something that got nicely fossilized.
I think it's the most important question we could have answered in sort of planetary science. And I would love to see a bunch of missions specifically designed to search for it or search the limits of it. As you said, Titan. Let's go to Titan. Let's go to Europa. Let's go to Enceladus. Let's go to Mars. Send a mission that's only job is to search for life under every nook and cranny, and let's find it. So I don't think, by the time we have this show again, I don't think we'll have a more definitive answer, because I don't think the tools have been built yet to get to the answer definitively.
And just since this is a pie in the sky episode, just to throw an idea out there, imagine that instead of trying to build an entire rover here on Earth where every nook and cranny is properly sterilized and this and that, and you have to worry about melting things when you irradiate it, imagine getting to the point where we can 3D print things in a zero-G environment so that they never touch anything else. And then we take this thing that we built in the vacuum of space without gravity, and that's what we use to explore, so that we have so much more capacity to make sure that stuff is clean.
Don't worry, aliens, we will have washed our spacecraft's hands.
Or just bubble boyed it.
Yeah, exactly. Okay, I got so many topics here. Let's talk about human spaceflight.
It feels like with human space flight, we're always 3 years away from the cool stuff. And we've been 3 years away from the cool stuff since we started recording in 2006. So I've given up hope, and I throw this one back at you.
Whoa! Okay, let's see. I think that the space station is going to get a bunch of stays of execution because it's very expensive and very cool, and they're going to keep funding it. Even if the Russians pull out, they'll keep funding it for literally as long as they can keep that thing going. And ideally, they'll just keep adding to it. I think the Chinese are going to probably be the first people to set foot on the moon, I think.
I can go with that idea.
Yeah, I think that's.
I support that.
Yeah, I think they're gonna be the next people to set foot on the moon. They're getting, they've got manned space stations. They've sent landers to the moon. They've sent missions around the moon to orbit it. Like these are all the pieces. They're making all the pieces,
motivated.
And they're motivated, and they got the money to do it. They literally just don't have necessarily the technology yet, and all the kinks worked out. But they've got everything that NASA's done to follow in the footsteps, everything the Russians have done, and as you said, the motivation.
And they're so savvy. They've been sending their best minds to the best universities around the world, and then recruiting them heavily to come back. I can't imagine the U.S. recruiting heavily to bring back its expats. That just doesn't happen.
Yeah.
And so they're working really hard to get their best minds to come home and to recruit some of the best minds from the rest of the world.
Yeah. So that's my feeling. If not, then we're looking at the NASA doing potentially its asteroid mission, but that still feels so pie in the sky. I mean, you've got the SLS, you've got the Orion, so you've got the capabilities.
I don't trust the SLS to actually get completed without getting killed by Congress.
So I was about to talk about that, but let's move on. Before we talk about SLS, let's talk about Mars. Do you think a human will land on Mars when?
2025.
2025. I'm going to push it 10 years after you. 2035.
I'm not saying they're going to live. I'm saying that some some crazy job that
Yeah.
gets a hold of a rocket, sends humans that way, and they die.
Yeah.
That's what I think is going to happen initially. And then everything gets put on hold for 10
Yeah.
years.
Yeah.
We're like, whoa, there's radiation. We need to figure this out.
Yeah.
Um,
I think that, I mean, you look at what's happening with SpaceX with Elon Musk, and he's absolutely committed, and I believe him that he's going to do it. It just, I don't know, it just doesn't feel to me like setting human beings down on the surface of Mars to live is as useful as perhaps learning to live better orbitally with, rotating space stations, things like that. Just been watching The Expanse too much, maybe, and it's really got me pretty stoked on sort of living on every nook and cranny in the whole solar system, and not just necessarily the big planets. But that's my feeling. So I think what you said, but then even more so. Let's talk about commercial private space launches. So,
okay.
SLS, you don't think it's gonna?
So SLS is bogged down by the bureaucracy of big government and lots of statutory regulations. Whereas SpaceX and these younger companies haven't had as many years to develop policies and procedures and paperwork and more paperwork. And as someone who works for a government university, I understand the difference in nimbleness that just comes from having layers upon layers of paperwork that is generally in existence because someone at some point in the past expletived up.
Yeah.
And so now there's a policy. Well, if you're starting from scratch, you don't have all of that history, and you also don't have the set in your ways. And this is something even just you and I have found, that as technology changes, you've come to me before and said, well, we need to do this. And I'm like, no, it's too hard. You can't do that. And you're like, but now we have this. I'm like, oh, new technology. Yes, we can do this.
Yeah.
Well, but if you're in a big company, you can't swing nimbly to take advantage of that stuff. So I worry that SLS is going to get caught up in bureaucracy and end up with lots of cost overrides and get brutally killed by Congress. And I don't see them having the same commercial contracts that you see with SpaceX and Sierra Nevada and Blue Origins and these other companies that are attracting commercial partners.
Yeah, I think what happens with the Falcon Heavy is gonna really answer a lot of questions, right? If the Falcon Heavy launches this year, which it's supposed to, and it's going to be the most, pretty much the most powerful rocket system and if it starts to integrate the reusable rocket systems, then the SLS is going to look like a really expensive option for NASA and for everybody. And if SpaceX can make it dependable and continue to bring the prices down, then it's just going to get harder and harder to justify any other launch system. Yeah. So
and it's not just SpaceX is the thing. We only talk about SpaceX because they're the ones that are doing the really awesome failure to consistently land correctly for NASA. But there are these other companies. There is Blue Origin. There is Sierra Nevada. There are others whose names never come straight to my mind.
I mean, don't count out Boeing and
Yeah, but Boeing is SLS.
Well, I understand that, but they have the Boeing has the Deltas and and Lockheed Martin, and they've got the Atlases, and right now I think the Atlas is the most powerful launch system on Earth,
right?
And available, and
those
the
are going
Ariane
to keep
5.
going.
Yeah, they're going to keep going, and they're watching SpaceX like a hawk, and they're integrating the kinds of changes that they make. But what they have is decades of experience in building these things and running these systems. So I don't think they're out of the game either. But I do think that we're on a whole new track of launch systems, and it's good. The competition is good. It's good for the people who are going to be buying these things. Yeah. I'm super excited. Okay, let's move on. Let's talk about stuff here in the solar system. So what about anything with solar astronomy?
I think we're going to continue to refine our understanding of the sun's upper atmosphere. It is still continuing to be highly mysterious. I think we will continue to see once a year slightly conflicting, but slowly moving towards convergence. Well, we now understand the corona has this effect because of this.
Right.
I'm hoping that as we move through another solar cycle, we start to with all of the space imagery we have going on to finally start to understand, if we see this in the imagery, it means this is about to occur. Being able to predict coronal mass ejections, being able to predict which sunspots will flare out when. I'm looking for consistent weather models for the solar atmosphere.
Yeah. And I think that's one that is really close, as you said.
Yeah.
You know, astronomers are fairly certain about the way these things work. Okay, let's talk about other stuff in the solar system, other planetary astronomy. Like, will we know what's causing those white spots on Ceres?
Oh, we already know that one. It's salts.
It's salt. Okay.
Yeah. Sorry, that one we figured out.
Okay. Anything else though?
I'm looking to find Planet 9.
Yeah, that'd be cool.
Yeah. So let's like, we need LSST. Well, actually, I don't know if it covers the right part of the sky. We need something to like look in all the right places.
Doesn't it cover the whole sky?
No, because it's in the southern hemisphere. So there's parts that it can't see, and I don't know the predicted where relative. It has the ecliptic. It can see the ecliptic, but I don't remember if Planet 9 sticks to the ecliptic.
Yeah.
I don't think it does.
What about planetary geology? And I guess we can say hydrology.
Yes.
There's so much water out there. You
know? We're going to start having sample returns, which is going to start allowing us to hopefully be able to understand the solar nebula that formed the planets a little bit better. I think that's going to be a whole lot of slow incremental change. The big thing we need to figure out is how the heck do we keep getting geologic activity on tiny things? Mm-hmm. Ceres had a volcano. Who would have thunk that? And Pluto, we have nothing. What the heck? So being able to figure out where tectonics comes from when you don't have the kind of active squishing that you get around Jupiter, and you just have free-floating things like Ceres and Pluto.
In the realm of asteroids, I think the search for asteroids is really going to continue, and astronomers will have nailed down the next class of asteroids, right? The smaller ones, the ones that are potentially threatening to Earth, down to the city killer size, right? We'll be down to the 100-meter size. Like right now we're at the 1 kilometer and above, but within the next decade or so, we should be down to the 100-meter and above.
Yeah, that's LSST's job.
And other missions that are potentially being put up as well. So
yeah, Gaia will also make major inroads into that.
Yeah, space. Oh, what's it called? Space defense. Space. Anyway, there's the one that there's the B612 Foundation's mission. I forget the Sentinel. So they're planning to put up Sentinel, which is another mission. So there's going to be a bunch of these. Okay, so let's talk about some stuff in sort of astrophysics and cosmology. So black holes.
They're there. They exist.
Yeah. Okay. I mean, we're going to have the Event Horizon telescope built, which is going to allow us to see the environment around a supermassive black hole, which is pretty spiffy.
And the kinds of physics that we're so close to being able to understand are things like, it looks like galaxies are probably spinning at their maximum allowed level, but we don't have data on very many of them. So I'm hoping in the coming years, as we're able to see with higher and higher resolution, the accretion disks right down at the event horizon, that we'll be able to do more to understand, well, just how are these suckers rotating? Because that does reveal itself outside of the event horizon. I'm also hoping that we're going to start to be able to figure out, why the heck don't we see more binary black holes in galaxies that clearly merged in the past? And maybe if we're lucky, catch some that are just on the brink of merging or have just merged. And not too close, because some things you don't want too close.
No. Let's hope for an observation of an intermediate mass black hole, which is still a bit of an elusive creature, and yet they should be out there.
I don't think it has to exist. I don't think we have to have intermediate black holes. I'm okay with not finding them. I'm totally okay.
I mean, that's the question, right? Do you think so? You don't think we're going to find them? Like if we would have found one
I think the formation mechanism for supermassive black holes is going to be found to be consistently different. We already know that the most massive galaxies from theoretical models formed all at once, possibly mostly in the early universe, and the smaller galaxies built up through combinations. The open question is, did the black holes in the smaller galaxies form in a similar mechanism to in the massive galaxies? Were they formed at the same time as the galaxy? That means that you can have supermassive black holes that never went through the stellar mass black hole size scenario. And this whole myth that we've had of lots of black holes merging and merging and merging, I don't think we need that story.
Right. So we're at this thought that maybe supermassive black holes just formed directly.
Yeah.
Yeah.
That's
Like
what I'm
just
looking to see.
A big blob of stuff turned into a supermassive black hole, and it never was a star.
All the computer models, we need to do all of them.
Yeah, yeah. Gravitational waves.
Ugh.
When will we find a direct detection of gravitational waves?
So everyone is making a whole bunch of noise about Lawrence Krauss's tweet after he got a text message, and how LIGO has everyone set aside for, what is it, in February or March?
Yep.
If
Chatter.
if that isn't a 6 sigma or higher detection, I'm ready to throw in the towel. I remember back when I was an undergrad in 95, when they started building the LIGOs, they were saying we're 3 years away from a detection. Well, no, it's been more than 3 years, guys.
Yeah.
Yeah. We've spent so many billions of dollars on these detectors. It's really hard to say this just doesn't work from the surface of an active planet. But my pessimistic gut is saying we're not going to detect them from the surface of the planet.
Wow. Now we know they're there. I mean, we've seen them indirectly in the way pulsar orbits, binary pulsar orbits interact, but they haven't been detected directly. And so you're thinking it's that advanced LIGO will probably not provide the level of accuracy that's required, and that it's going to take something space-based like LISA.
Yeah, I'm being pessimistic on this one, fine. But the noise is just far too complicated to get out of the system, I think.
That's super interesting. Okay. Speaking of physics, let's talk about some particle physics. What kinds of, the Large Hadron Collider turned up the Higgs boson on our watch. What's next, do you think?
I'm hoping that we start to find, not necessarily in the particle colliders, but perhaps in the underground tanks, particles that correspond to dark matter. Just like we're detecting neutrinos, well, dark matter is probably a particle very similar to neutrinos. So what I'm looking for is that next flicker in a tank that says, hey, I'm dark matter.
So based on that, I mean, I think the other big hope is that people are going to see, some particle from supersymmetry. Which theoretically should be in the capabilities of the Large Hadron Collider. Okay, so let's just go to dark matter then. Do you think we're going to find out what dark matter is?
I'm hoping. I'm hoping that we reveal that next tier of particles that come and join the standard model that gives us dark matter. So the open question is it supersymmetry, or is it just another column that we hadn't thought about? I mean, we're finding these 5 quark bosons now.
Yeah. I mean, I ask this question to everybody who knows anything about it, and it does feel to me like people feel pretty hopeful that the right apparatus is in place now, the right detectors are in place, the right, the LHC is there to try and actually generate these particles, that all the tools are there now to kind of get to the bottom of this.
We are going to have to crank up the energies more than I think the people who built it are entirely comfortable with.
Yeah.
But that's always the case.
Yeah. Well, I mean, as always, they're going to push that thing to the absolute limits and take it way further than anyone ever expected. Okay, dark energy.
Yeah, I'm out.
Yeah,
no idea.
No, and And this is the same. I asked the same question. They were like, dark matter. I'm like, yeah, I think we're pretty close. Dark energy. And they're like, I have no idea. I have no place to start. I got nothing.
Yeah. So I think the next big push is to verify that dark energy's density has been constant through the age of the universe. And there's some really cool instruments and missions planned. The Dark Energy Explorer down at McDonald Observatory is one of them, that will start to get us there. But they don't tell us what dark energy is. They just tell us where it was and when it was. And I honestly am thinking this falls into the category of one of those things that we just need a theoretical genius. We need that Einstein to come along and give us a new perspective.
Yeah, I talked a bit to Paul Matt Sutter, and he kind of feels, like it's still way out there that there is some kind of connection between dark matter, dark energy, but it's still just all so out there that I'll bet you 10 years from now we'll still be talking about dark energy, and we're just still going to be.
Well, it depends on if we get that genius or not. You can't predict geniuses.
True. Yeah.
And this is why we need more diversity in astronomy, because we don't know where that genius is coming from. So
it could be you.
I know it's
well,
not
I mean,
me.
it could. Oh,
it's true.
I was saying it to the listener, but I'm also including you, Pamela. Okay, let's talk about Big Bang cosmology then.
I'm happy with it. We're going to continue beating down the error bars at this point. We're going to continue better constraining all of the different variables. I love the fact that when I started in astronomy, everyone was like, use a Hubble constant of 100 for H naught, because it just makes the calculations easier, and we don't know. Yeah. And now it's just like, we know, and we have small error bars.
It is,
Yeah. So let's just keep going with all those parameters, beating down the error bars, and that will make the search for dark energy more accurate.
What about inflation? I mean, we were all excited that we found primordial gravitational waves
that we did
to help out with inflation. Now we're back to square one. Do you think we're going to find evidence for inflation?
Not unless we build another space probe. I don't think we can do it with Planck. I think if we could do it with Planck, we already could have. I may simply be pessimistic, but that's my job on this show.
Yeah. You're the pessimist. You're the hardened realist, and I'm the wild-eyed optimist. Okay. So anything else maybe in the Milky Way? I think one thing that's going to be intriguing is this. We talked about this idea of the alien megastructure, which is most certainly not an alien megastructure, but it's a very weird object, a very strange kind of star that's been dimming over a long period of time, and something is transiting in front of it. Is this a whole new class of object?
I think that we're going to continue to realize that solar systems do things we never predicted, because we had a sample size of 1 when we built all of our models for solar systems. So that one I put out there with anything a science fiction writer could come up with is probably not as crazy as reality. So planetary systems will continue to shake the foundations of our lack of understanding. But what I'm really looking forward to...
So vague. Okay.
What I'm really looking forward to is I had the sudden realization last week that graduate students are now starting to factor in being able to use the James Webb Space Telescope while they're in graduate school. Yeah. And I was like, whoa, we're that close that students aren't afraid to require it to do their dissertation. I don't think that's wise. I don't think you should do that. I'm a pessimist, though.
Totally should do that.
But the thing is, with James Webb Space Telescope, we're going to be able to start doing infrared astronomy that when we partner what's possible with ALMA, with what's possible with James Webb, we're going to nail the early days of star formation. So understanding how these molecular clouds collapse, how we get stars turning on, understanding the initial mass function, all of these awesome things, where planetary systems do and don't form. We're going to get details on that, and it's awesome.
But, we're not just talking about the star formation within the Milky Way. I mean, James Webb will be able to take us right out to the very edge of the observable universe and see.
But it won't be able to peer into ISM in the early universe. It will be able to tell us when galaxies lit up.
But
so
it's
that's
right,
the
exactly.
other side of it.
Right. And so it's going to show us both sort of on the near side, stars forming and sort of what goes on in those surroundings. But in the far side, it's going to let us see right out to the very edge. The stuff that Hubble has to do, these crazy, microlensing bank shots, James Webb is just going to brute force and go, gaze like the Eye of Sauron onto all these different objects. So I'm totally stoked about that. Anything else kind of in extragalactic astronomy?
Well, I'm going back to James Webb and ALMA. We're starting to figure out when stars turned on, and I'm hoping we'll get the right kind of data to finally be able to say something sensible about how low metallicity stars formed and exploded, and at what point all the types of supernovae started to occur, so that we can decouple all of the different problems with white dwarfs having different chemical compositions with possibly different masses. There's so many different issues with supernovae when we start mucking about with metallicity that we think we know, but with James Webb we'll actually know.
And this gives us some of the answers to the kinds of questions that we talk about here on Astronomy Cast, right? Is like, how long has life potentially been around? And that's been dependent on those heavier elements. And so the question is, when did those heavier elements really start forming? That'll give us some baseline, some boundaries for answering like the the Drake equation. How long has life been around to evolve, to ignore us?
When did the stars turn on, and when did they die violently and like enrich everything around
and
them?
when did you have enough that you could get life? So very cool. Well, you know what? We're out of time. So I hope we'll pick some time in the future. We'll come back around and we will take another look and see if we can make an update on when all this stuff happened. And then we can go, we were right, we were wrong, we were right.
Exactly.
Yay. All right, thanks, Pamela. Save.
Yep. I cannot find the button. There it is. I'm still not used to Audacity.
Sorry, everybody. I'm just saving, making everything safe.
Yeah. We like you. We want to give you our audio later, without any of the potential weirdness that comes with the YouTubes.
Yeah, this is the nice, raw, high quality one.
Yeah.
Okay. We've got about 12 minutes to do some questions.
Okay. So, Elad Avron says, not a prediction, but more of a wish. I want naked eye supernova already. Yes.
And a nice naked eye comet, please.
Yeah, I guess. Yes, Catalina didn't quite count, did it?
No.
We need another Hyakutake.
Yeah, or Hale-Bopp, or what was that? Forget, what was the one that came?
Two big ones.
Out of the century.
Oh, McNaught.
No, the one that we had. We've already forgotten it, which is probably best. Okay. It let us down. Okay.
Oh, the one that fell apart on the other side of the sun.
Yeah.
Yeah, the Thanksgiving Day destruction. I don't remember its name either. It's dead to me. And it's dead to everyone.
Yeah. Tom Matey asks, what about deep space rocket propulsion technology? What might work?
We have ion drives. They are a thing.
Mm-hmm.
They're just slow.
Mm-hmm. What about the EM drive? Oh, we didn't even talk about that.
I don't know enough about that.
Weird electromagnetic. No, so I mean, there's the weird electromagnetic drive that was found, that people keep confirming. Even NASA keeps confirming that, there's something weird going on here. It's not nothing, it's something. So
I don't know anything about it other than, yes, there keep being articles about it.
Yeah. Darren Dempsey says, hey guys, this is my first live stream from Nanaimo. Hey, Darren. I'm in Courtney on the same island.
Where is that?
Nanaimo is like about 150 kilometers south of me on Vancouver Island.
Okay.
Guido Bieber says everything would be best to put under CosmoQuest, really, although separate channels would be great for the overall branding, maybe. So that's sort of what I was saying.
Yeah.
John S. says that anything with the name of Mark Watney will be banned from Mars missions. I think that's best.
Yes.
Yeah. Noel Rippenthal asks, how soon will we have on-orbit experiments with centrifugal gravity? I think that's a great...
We've had them at low sizes. We've had small size centrifuges launched before.
Yeah.
It's just the size.
Yeah. I mean, having human spaceflight that doesn't tear the body apart really wants some kind of centrifugal system, right? Space station a la 2001. You need that thing to rotate.
And this is a solved problem.
Yeah. Well,
Babylon 5.
Oh, yeah, it was solved by Babylon 5. It was solved by 2001. No, it's the actual physics of setting something that big up there and getting it rotating and all of the wackiness that would ensue with that is still, not fully solved, but I think that's...
I wish Bigelow had more money, because I'd love to see what Bigelow would do with unlimited funds and blow up.
Guido Bibra predicts that Elon Musk is going to go to the ISS in maybe 4 to 5 years, and SpaceX will probably try to get to Mars and back sometime between 2025 and 2030, although backed by whom is anyone's guess. Maybe China. Cool. I'd love to hear some of your predictions. This is awesome.
Yeah. So Darren Dempsey asks, what about the new planet in our system? Yeah, that's Planet 9, and we're pretty sure it exists mathematically. Now we just have to see that sucker, which is...
Gravitationally.
Yeah. Gravitationally we can see it. We just haven't seen light reflecting off of it.
John S. says the next 10 years, adaptive optics will be available to rich amateur astronomers. In 20 years for everyone. I think we're already there with adaptive optics for rich amateur astronomers.
I know that you can already get the tilt tip plates, and those are built into some of the CCDs.
Yeah. Oh, I forgot to turn off pause my Dropbox. I'm going to do that now.
Oh, yeah, I made the same mistake.
So everyone's like,
hello.
Pause. Okay. Voyager 2, this is John S. says Voyager 2 will return to Earth and want to meet its creator. Clint Eastwood and a bunch of other has-beens will be sent to space to sort it out. Probably Bruce Willis.
I love that. Someone needs to make a webcomic of that. If any of you, I want to see what Zach Wienerstein, how do you say his last name? I only read it.
Oh,
Saturday Morning Breakfast Cereal Zach.
Yeah.
I'd love to see what he would do with that.
That's awesome. Tom Nathy says radio and optical SETI is a dead end. Oh, Tom.
I kind of agree with him.
That's so mean, but I totally agree with you. For the reasons that I just said. So, okay. Ashwin Raguraman asks, did we talk about Lisa Pathfinder already? We did. I hope you caught that.
Yeah. We mostly talked about LIGO doesn't work good as space. We didn't say Lisa.
Yeah. All hail Lisa. Ison. Ed Thompson's talking about Ison. Yeah, you see, I had already blocked that chunk of my brain away in sadness and regret. Universe, you owe me a comet. And all of you. And everyone else too.
But don't hit us with it. Just we want naked eye, but not too close.
Oh, but it would be spectacular. Westby says the most powerful of the active launch is the Delta IV Heavy. After that, it's probably the Ariane 5, Delta IV, Proton, probably the Long March 3, then Atlas 5, Falcon 9. Okay. I thought it was the Atlas, but okay. I literally just looked at this. So.
I thought we were out of Delta IVs.
Delta IV Heavies?
Yeah.
Oh, maybe. Darren Dempsey says, what about the warp drive? Is it possible? Real?
No.
No and no. Well, is it possible? I mean, maybe, but there's in a sort of a theoretical, the guy working on this for NASA, a guy named Sonny White, I talked to him a few years ago, and he said, yeah, warp drive, maybe. I mean, you need all of the energy in the entire universe to make the thing go, but maybe. And then his more modern version of it is like making some kind of directed warp field that maybe you just need the energy of an entire solar system to pull off. So it's, it's better.
We need to Tesseract.
Yeah. Tom Stranicus says the James Webb Telescope near IR camera will break on launch.
No.
Oh, if that telescope crashed.
If JWST does not work successfully, there's going to be a collective scream that makes what Ben Kenobi heard when Alderaan was destroyed minor.
Yeah, it was like a million grants going out.
Yeah, and it's easier to get new life than it is to get new grants.
So Thomas Traniker is making some predictions. He thinks there will be a big dispute about some minor part in research in exoplanets. Okay.
Of course. That's normal.
Course. Yeah, that's like
we call
normal.
That tomorrow.
Yeah, we call that Wednesday. Thomas Traniker says prediction number 2, the universe will be older than we thought. I don't know. Only like a little bit within the error bars. Darren Dempsey asks, what's the next space-based telescope after James Webb?
We don't have one.
No, there is none.
And there's no optical one planned at all. So once we decommission Hubble, we're kind of out of luck, but at least we have all of the great European Southern Observatory scopes.
I think one of the things that people are going to be really amazed is how much of this technology is coming back to the Earth. That the telescopes are getting so big and so powerful and so capable here on Earth, and they're turning into the adaptive optics and these interferometry that you're gonna want to go to space to do things that really need to be above the atmosphere, like X-rays, things like that. But for a lot of the wavelengths that does make it through the atmosphere, these telescopes are just astounding. Yeah. The 30-meter telescope is going to outclass Hubble. From the ground.
I'm waiting to see what its suite of instrumentation is, because a lot of these things really sing when you're doing spectroscopy, but trying to do imaging is significantly more difficult.
Billy Gordon and Elad Avron are predicting that Betelgeuse will explode. So I'm in. Let's do it. Goodbye, Betelgeuse.
Is more likely, but that's me. No, you're all about your Betelgeuse.
I'll take them both. I'll take either one. Kaboom. Okay. And as you said, Elon wants to see a naked eye supernova. So I think those are all the comments that we got this week. Cool. Why don't we wrap this up?
Cool.
Elad Avron predicts that X-Files return for its 11th season. Oh, don't.
Didn't they just start?
And Richard Strassel predicts that the media will blow a story way out of proportion.
Yes.
No.
That's a given.
Not a chance.
No, you'll never do it. It's the rest of the media that will do it.
No, I won't get sucked into one of those. Okay, cool. Well, let's wrap things up. So thanks everyone for joining us on this journey today. Really appreciate it. If you haven't already, make sure you subscribe to this channel so that you'll get a notification when we go live next time. And prepare for some weird fluctuations in the internets while we try to move to the new system. That's it.
Let me know if you think all of CosmoQuest's stuff should go to the 365 channel.
That sounds good. Awesome. All right. Well, thanks, Pamela. Thanks, everyone, for watching. We will see you all next week.